Make sure you are paying attention. So today we're going to go over law of cosines. So the past few days we were going over law of sines. Today we're going to go over law of cosines. Okay, so with law of sines you were using sine of an angle. With law of cosines you're going to use cosine of that angle. So the law of sines can be used to solve a triangle if the following information is given. So if you have angle, angle, side, angle, or side, side, angle. Okay, so all of those cases would use law of sines. Now to use law of cosines, you would need the measure of two sides and the included angle, known as side angle side. Okay, so it has to be side angle side, or the measure of all three sides, which is side, side, side. Okay, so law of sines is those top three cases. Law of cosines is side angle side, or side, side, side. Okay, that's the difference between law of sines and law of cosines. So the law of cosines in triangle ABC, if sides with lengths A, B, and C are opposite angles with measures A, B, and C, respectively, then the following are true. So we have A squared equals B squared plus C squared minus 2BC cosine of A. So that's the one I think you're going to use the most here. Okay, so that is your formula for law of cosines. What I want you to notice in that formula, you only have one angle. Okay, that's your capital letter. Okay, this one angle is angle A. Okay, so if I'm looking at that angle given, its opposite side is what goes on that other side of the equal sign. Okay, so its opposite side is lowercase a. That is what goes on this side of the equal sign. So if you look at the other two formulas, so if you start at angle B, again, lowercase b is on that left-hand side of the equal sign. Your other two sides are A and C. That's what goes in this section here. Okay, so the opposite side is always on that left-hand side of the equal sign. So we're going to go through some examples using law of cosines and solving a triangle just like we were doing with law of sines. So example 1, we have triangle FGH. So I'm going to draw that triangle. Okay, and you do need a calculator today. So if you have a calculator, make sure you take that out right away here. Okay, so I have triangle FGH. Angle G is 82 degrees. Okay, lowercase f, so that's the side opposite angle F. That's 6. And H is opposite side angle H, so that's 4. Okay, so we need to find angle F, we need to find angle H, and we need to find lowercase g. What? Okay. So we do need to use law of cosines because we have a side, an angle, and a side. And that angle is included between our two sides given. So I am just using this form here. So I'm going to use the angle. Okay, so I'm only given one angle, right? That's what has to go in this A position. That'll be 82. That means its opposite side has to go on the left-hand side of this equation. So this one's opposite side is G. So I would say this is G squared is equal to, my other two sides are squared and added together. So that's 4 and 6. So we have 4 squared plus 6 squared. Then minus 2. Again, we have B and C right here. So those are 4 and 6. And then cosine of the angle opposite the side we started with. So that would be cosine of 82. Okay, do you understand how I set that up? Okay, from here I'm just going to simplify. So I have g squared is equal to 16 plus 36 minus, I can multiply all three of these numbers together here. So 2 times 4 times 6 is 48. Okay, now you do have to kind of be careful with this. So I can add these two together, but I cannot subtract 48 from that. So I can add these two terms together to get 52, but do not subtract 48 from that. All right, so I still have this g squared, correct? To get g by itself, you take the square root of both sides. So this is what I would plug into my calculator. That's square root of 52 minus 48 cosine of 82. Okay, so plug that into your calculator. Make sure you can get the correct answer. Okay, so square root of 52 minus 48 cosine of 82. And you should get g is equal to 6.7.
Can we just put the first one?
You could.
So
So you could do the square root of this entire quantity, yeah.
That's what I'm doing.
That's fine.
that's only if you don't have
So,
the one across from it. That
right,
makes it-
so that would, you do the square root if you don't have that side across from
Okay.
that angle.
And then we just do what we can do,
Easy.
or do we have to?
You can do law of sines after you find that side.
That's it.
But we want to solve for these two angles here.
Yeah,
Yet
that's what I'm saying.
you can use law of sines, but I'm going to show you the cosines way. So I still need to solve for angle F and angle H. So I'm going to
Technically,
solve for angle F. Okay, so I'm going to solve for angle F here. So that means the opposite side to angle F is 6, right?
Yeah.
So 6 has to go in this a squared position then.
yeah.
Okay, so I have 6 squared is equal to my other two sides squared and added together, right? So I have 4 squared plus, I just found g, that was 6.7 squared, minus 2, again, times those two other sides, then cosine of the angle opposite the side I started with here. So that's cosine of angle F. Alright, so again from here I'm going to square my terms and then multiply these ones. So 6 squared is 36, 4 squared is 16, 6.7 squared is 44.89. My three terms here multiplied together is 53.6. Okay, so again, I can add these two terms together. So I have 36 is equal to 60.89 minus 53.6 cosine of F. Now again, you cannot subtract these two numbers. Okay, this 53.6 is attached to this cosine of F. So you can't subtract those two. So I do want to get cosine of F by itself. So I'm going to subtract 60.89 from both sides of my equation to get negative 24.89 That's equal to, I still have this negative 53.6 cosine of f. I'm still trying to get cosine of f by itself, so what should I do?
Divide by 53.
Now you can divide these and get a decimal. I'm fine with that, but I'm going to leave mine as a fraction. Okay, so if I have a negative divided by a negative, it is a positive. So I'm just going to leave it as positive then. And that's equal to the cosine of f. Now if I'm trying to find an angle, what do? Inverse. Good. So I'm going to bring in cosine inverse. So I have the cosine inverse of that fraction, 24.89 over 53.6, and that will equal angle F. And you can plug that into your calculator then. I got 62.3. If you want to round to the nearest degree, that's fine if you write 62. Okay, so angle F is 62.3. So now I have two of my angles, right? To find the third, angle H. Subtract both of those from 180. Okay, so subtract the two angles I know from 180. And that's 35.7. Or 36 if you rounded this to 62. Okay, so again, you're finding all the missing pieces of that triangle. We're just using law of cosines. And Ethan pointed out if you want to, after you find that last side G, you can use law of sines to find that angle as well. Okay, so you can mix those up to figure that out. I just wanted to show you how to find an angle using law of cosines. Okay, questions on example 1, how I set up the problem. You're just using that formula. Are we good? Can we go to the next example? No, we can't. We can't? Then you're not going to get your assignment and you're going to get no time to work on it. No. All right, so when you're only given the three side lengths of a triangle, you can solve it by using law of cosines. So the first step is to find the measure of the largest angle. Okay, this is done to ensure the other two angles are acute when using law of sines. Okay, so again, what I highlighted here, your first step is to find the measure of the largest angle. So that means that capital letter attached to the cosine in law of cosines, your opposite side has to be the largest side. So in this case, which one of these angles, A, B, or C, would be the largest angle? B. Okay, because side B is the largest side. So angle B has to be the largest angle. So that means using law of cosines, I have to find angle B first. So still using my formula from the front. Okay, so this is your law of cosines. Just using this formula. Now, since I'm finding angle B, angle B has to go in this spot, right? Okay, I want to find angle B first. So my variable, angle B, has to go in this spot. Meaning what has to go in this position right here?
11.
No. 11.
Because we're finding B.
Because you're finding B.
Not A. Come on, guys.
So if I plug in B here instead,
Come on.
that means lowercase b has to go in this spot. Okay, so I'm plugging in 11 for this spot here. So I would have 11 squared
5.
is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of b, since I want to solve for b first. Okay, next, square all your terms here, multiply these three together. So I have 121 equals 25 plus 64. Okay, minus 80, cosine of b. Okay, again, I can add these two together, but don't subtract 80 from it because that 80 is attached to the cosine. So 121, hey, shh. I have 25 plus 64, that's 89, minus 80 cosine of b. What's my next step?
Well, we gotta
Divide.
take. No.
No.
Minus.
Minus. Okay, that's 32 is equal to negative 80 cosine of b. Now we can divide by negative 80. Okay, so I have 32 over negative 80 equals the cosine of b. To get b by itself, you bring in cosine inverse. Okay, so in your calculator, you can plug in cosine inverse of negative 32 over 80, and that will give you angle B. Okay, so angle B will be 113.6 degrees. So that was finding angle B. I still have to find angle A and angle C. Now again, you can use law of sines from this point if you want. So if you draw in your triangle, since I know law of sines is easier, right, we have our triangle ABC. We just found angle B is 113.6. And we know all three of the sides. Okay, so we know side B is 11. That was a bad 11. Side A is 5 and C is 8. So if you want, we can use the law of sines to find angle A, right? So we can do sine of our angle over its opposite side equals sine of angle A over its opposite side. So if you want to use cosines and then sines, you can do that. If you want to use cosines, law of cosines to find that next angle, you can do that as well. Okay, so it's interchangeable. Which one do you want me to do? Cosines. Cosines? All right, so I'm going to solve for angle A then. So if I'm solving for angle A, what goes in this position here? The small a, which is 5. Good. So I have 5 squared. Okay, then I have my B and C values. So 11 and 8. So we have 11 squared plus 8 squared minus 2 times 11 times 8 cosine of A. Okay, so again, square our values. We have 25 equals 121 plus 64. Multiply all three together. That's negative 178. 6, not 8, 6. 6. I looked at my 8 when I said it. Okay, now I can add my two terms together right here. So we have 25 is equal to 185 minus 176 cosine of A. Oh, my paper's sideways. Yep. Subtract 185 from both sides. To get negative 160 equals negative 176 cosine of A. Divide by negative 176. Again, if I divide a negative by a negative, it is positive. So I have 160 over 176 equals the cosine of A. Okay, then cosine inverse to both sides. So we have the cosine inverse of 160 over 176 is equal to angle A. What? Why not? I got 24.6.
Did that in her head?
Yep, I did that in my head.
It's smart.
I did not do that in my head.
That's why your math is smart.
All right, so I have two of my angles in my triangle. So to find angle C then, take 180 minus the two angles you found. And angle C will be 41.8. Do we understand how to use the law of cosines formula?
Yeah.
So whatever angle you're giving, or if you're not given an angle, you have to put on the left-hand side of that equal sign, whatever side is opposite that angle. Okay, then the other two sides go within the right side of that equal sign. Okay, and they don't have to go in a specific order there. So you could flip-flop C and B here, and you'll still get the right answer. Okay, flip-flop C and B here, you'll still get the right answer. It doesn't have to be specifically in that order. As long as whatever angle you're looking for, its opposite side is on the left-hand side. Okay, then the other two sides you can just plug in to either one of those spaces. All right, so last problem here. You can use the law of sines and the law of cosines to solve problems involving oblique triangles. A triangle, that's a triangle with no right angle. So you need to know the measures of at least one side, and any two other parts of the triangle has a solution. You must decide whether to use the law of sines or the law of cosines. So the reason I wrote these up here at the beginning of our note sheet, so if you have any of these cases, you use law of sines. If you have either one of these two cases, you'll use the law of cosines. Okay? So you have to check that before you start your problem. So in example 3, Amelia ran 6 miles in one direction. She then turned 79 degrees and ran 7 miles. At the end of the run, how far was Amelia from her starting point? Okay, so if she starts here at this point, she ran 6 miles in one direction. Okay, She then turned 79 degrees. Okay, so we'll say this is her 79-degree turn. And she ran 7 miles then. Okay, and what we want to figure out is how far away she is now from her starting point. So that means we're trying to figure out this distance right here. So looking at my different cases at the beginning of your note sheet, I have a side, then an angle, then a side. So which law should I use?
Cosine.
Yeah, I should use cosine. You're right. So I do use law of cosines. So I have an angle between my two sides given. That's why I'm saying it's a side angle side case. Okay, and that is law of cosines. So I'm trying to find this side right here. Okay, so again, using our law of cosines, we're taking our angle we're given. Okay, that's 79. That's what goes in this capital A spot here. So that means what goes in this spot here in our picture. Okay, 79 goes in this capital A spot. What goes in this A squared spot?
66.
You said you went up
79, it's the biggest one.
79 degrees is your capital A. That's your angle.
Yeah, so across would be X.
Across would be X. Yes.
Oh.
So you need the side opposite that angle to go in that lowercase a squared spot. So we would have X squared is equal to your other two sides are B and C. 6 squared plus 7 squared minus 2 times 6 times 7. And then cosine of your angle given is 79. Now, yes, in your calculator, all you would have to do is take the square root of both sides. So if you can plug this entire quantity into your calculator as is, you can do that, and it'll spit out your answer right away. So see if you can do that before I get any further here.
72.
What?
No?
No.
I tried doing it in my head. No.
7 times 7 is 49.
8.
Good job.
6.
Not 0.6.
112.2.
112.
8.4.
8.3.
Oh, what? Was it? I wasn't even.
That was just straight up guessing too.
It's 8.3 miles. So in your calculator, if you couldn't plug it all in right away, square each number, multiply them together, make it a little more compact, and then you can take the square root of both sides and enter it in.
Good answer.